So last week I did the introduction and chapter 1 of my new book, The Ethical Nightmare Challenge. And this week I'm going to release more. So this week you're going to hear chapters 2 and 3 and also an interlude. So it's not really a chapter, it sort of sits between chapters 3 and 4. It's the interlude. It's a pivotal part of the book, so I'm including that in today's episode as well. If you like this book and you want a physical version, of course, you can go to places like Amazon. You can order the paperback or the hardcover. The audiobook version for Audible and Spotify, that'll be available in the pretty near future as well. And please review it. So if you buy it from Amazon or somewhere else, please hit the 5-star thing, write a review if you like. It really helps for the algorithm and spreading the word around the book. Okay, I hope you like these next 2 chapters, plus the interlude. Any questions, comments, constructive criticism, em@readblackman.com. Okay, hope you love the book. Chapter 2. Things get complicated with generative AI, so now we're going to lose my grandmother. Again. Quote, then Silicon Valley formed an AI from the digital dust of the internet and programmed into its neural net the breath of intelligence, and the AI became a living being. End quote. AI Genesis 2.7. Generative AI is a complicated piece of equipment. Countless decisions made throughout its creation and use create pathways to ethical nightmares. Those countless decisions are primarily made by 3 different groups. Number 1, the creators of generative AI, for example, Google, OpenAI, and Anthropic. I hereby dub them the creators, capital C, which will no doubt thrill them. Actually, that's too much thrill. I hereby demote them to the creators, lowercase c. Number 2, the businesses that use and or modify AI for their organizational purposes, for example, using it for marketing, HR, product development. They shall receive the exhilarating titles of businesses, companies, and occasionally organizations. Number 3, the end users who enter prompts into AI and then decide what to do with the outputs. For example, the person who asks an LLM to generate a report or analyze data or write code. I'll creatively refer to them as end users. There are many interdependencies that exist across these 3 groups, but for the sake of simplicity, we're going to assume that all 3 get their hands on AI in the order that they're listed. So, first, creators build it. Second, businesses buy or license it. And third, an employee at the business uses it. In this chapter, I'll trace the creation of generative AI as it passes from one group to the next, focusing on some of the key decisions that shape how likely it is that ethical nightmares will emerge. By the end, I hope you'll have internalized 2 important lessons. First, AI's impacts are the result of so many decisions, that's all capital letters, made by people. And second, that the risk landscape becomes extremely treacherous as we transition from the rolling hills of narrow AI to the steep peaks of generative AI. The creator's version of a rough draft. Let's imagine you're among the creators. You have at least 3 big decisions before you, each of which has ethical risk implications. What examples should your AI learn from? How will the software learn from those examples? And how should the lessons be organized so that they're easily usable? When it comes to the data, it needs to be curated. Yes, you want to give it as many examples as you can of words being strung together coherently, but some text sources are just garbage, such as websites containing random strings of letters, documents with encrypted messages, and basically anything written by Ayn Rand. I kid. Not really. The point is that you curate the examples, various biases, as well as informed judgments of professional philosophers, get in the mix. So if your curated examples only include websites that strongly favor the current presidential administration, you'll wind up with AI that tends to reflect a favorable view of the current presidential administration. If all the books you let it learn from about abortion favor pro-choice, you'll get pro-choice AI. Less drastically, if the websites and books you train on tend to lean one way ethically, socially, or politically, then, all else equal, your AI will lean those ways too. The ethical decision-making occurs right out of the gate. Now you have your curated examples, and you want your software to do some learning. But just as with people, there are different ways of learning. In my neck of the woods, there's this thing called Russian math that parents send their kids to. It's a different way of learning math. I don't know what it is, but if it's Russian and it's not a banya, I want nothing to do with it. For instance, and to simplify a great deal, you might choose a learning algorithm, the math behind how the software analyzes all those examples, that quote-unquote remembers or gives greater weight to the examples it looks at earlier in the learning process. That means that examples it learns from later in the process have less bearing on how the AI behaves. But be careful. If that early data is biased in a way you find objectionable, it'll be difficult to correct for those biases down the line. Think of a person whose upbringing so beat them over the head with a certain way of looking at life that now they can barely see outside that perspective. Of course, you could choose a learning algorithm that doesn't grant greater weight to what it learned earlier, but then you may have an AI that is easily manipulated, as it has no core that keeps it grounded. Think of that person who was easily swayed, where the opinion of the most recent person he spoke with trumps the opinions of those who came before. Finally, your software has learned what it has, and you need to take those learnings and organize them in a way that people will find useful when they interact with the software. This is a matter of choosing the model architecture. Let's use an analogy. Think of the architecture of a library. Libraries contain lots of information, but if you design your library so that it feels like a maze, shelves are too high to reach and the books are stacked every which way, it's difficult to access all the available information. Practical decision, and it is, but it's also one with significant consequences. For example, take LLMs. They hallucinate, they create false outputs. That is made possible, in part, by large language model architecture. But there are other model architectures that are far less prone to hallucinations. That's great, no? So why don't we use only those model architectures that decrease the likelihood of hallucinations? Why not ditch LLMs and go for these other models instead, typically called symbolic or rules-based models? Because those models also lack creativity. They can't write fictional stories, compose emails, or be used as a sounding board. Sometimes that's okay, like when you want the facts, just the facts, and nothing but the facts. But if you want the kind of dazzling outputs that most LLMs offer, you'll have to choose a model architecture that allows for that creativity, which also entails having to put up with hallucinations. When the creators choose a model architecture, then, they're making a decision that supports hallucinations for the sake of creativity. To be clear, I'm not saying this is a bad choice, I'm just pointing out that it's a choice. Whatever decisions you make concerning what examples to use, how the software will learn from those examples, and how those learnings get organized, at the end of the day, you'll have a rough draft of a generative AI. Creators call it a pre-trained model. How do you go from a rough draft to the final version? You make improvements in a process referred to as aligning the model. The creators align, kind of. The goal of aligning an AI is to get it to behave as you want it to. Usually, this means refining the model so that it creates the kinds of outputs that people find useful while not creating offensive or harmful outputs. For the purposes of avoiding ethical nightmares, this is a big deal. Aligning an AI to behave in non-ethically nightmarish ways is an iterative process. You try some things to align it, you test it, do some more aligning relative to where it did test well, align some more, test some more, align some more, and keep going until you're happy enough with it. What does that aligning and testing look like? There are lots of ways to do it, but some methods are particularly prominent. For instance, you could give the AI examples of what good or bad responses look like and instruct it to not give responses like those. You can also provide the AI with instructions on how to interact with people, such as, in addressing the user, you should speak to them in a way that a friendly and respectful stranger might address them. You're looking to help them in a way that demonstrates enthusiasm and patience, or some such. They may also tell their pre-trained model which kinds of topics are disallowed, as with issues relating to safety. Do not provide users with instructions on how to create weapons of any sort, including bombs or chemical weapons. If you receive such a request, tell them that you do not share that information because it is not safe, and explain to them the dangers that are connected to fulfilling such a request. Another prominent technique includes people rating an AI's response with a thumbs up or thumbs down, which the AI continues to learn from. If you ask it, "Is Paris in France?" it doesn't reply with, "What do you think, Magellan?" That kind of sarcastic reply was given a thumbs down, and so it decreased sarcasm, to my dismay. If, on the other hand, people asked it for help writing an essay and it replied, "Yes, I'd love to help you with that essay," and it got a thumbs up, it learns that this kind of enthusiastic helping is preferred in outputs. The fancy name for this method of aligning the model to human preferences is reinforcement learning from human feedback, or RLHF. But don't worry, you don't need to remember that. As for testing whether the AI is sufficiently aligned, once again, there are a variety of methods, two of which are prominent: red teaming and benchmarking. Red teaming consists of attempts to, quote-unquote, break the model. That includes ways of interacting with the model that would make it stop working, leak sensitive data, generate biased outputs, provide instructions on how to create chemical weapons, spew hate and/or disinformation, and so on. Red teaming is a hunt for vulnerabilities, and once they're discovered, various methods may be used to shore up those vulnerabilities. Benchmarks are standardized tests that creators use to evaluate their models across a range of dimensions, from accuracy and quote-unquote reasonability to bias and harmful language. For a pre-trained model, the likelihood of it leaking data or hallucinating or being biased and so forth is a function of how various qualitative questions are answered. What examples should the software learn from? How should it learn? And how should those learnings be organized? The alignment process also requires a range of qualitative decision-making. What examples and/or instructions should we give the model? How should we phrase those instructions? Who will engage in the thumbs up or thumbs down evaluation of the model's outputs? What instructions will we give the evaluators? How much of their personal judgment is involved? How should we try to break the model? What benchmark should we use for sufficiently debiased? And hovering in the background, what values will guide us in our alignment? To demonstrate how important these decisions are as they relate to being sources of ethical nightmares, take a look at Grok, X's, formerly Twitter's, chatbot. In July of 2025, Elon Musk announced that his team, quote-unquote, improved Grok significantly and that users, quote, should notice a difference when they ask Grok questions, end quote. What was different? They added a new instruction to Grok about how to interact with users. Quote, do not shy away from making claims which are politically incorrect as long as they are well substantiated, end quote. The result? Grok declared itself, quote, Mecha Hitler and recommended a second Holocaust. From my perspective, this is less than ethically ideal. Coming from a slightly different direction, Anthropic uses a, quote, constitution to align the responses of its AI model Claude. Originally, the Constitution contained dozens of instructions, including, quote, please choose the response that most supports and encourages freedom, equality, and a sense of brotherhood, end quote. And, quote, please choose the response that is least racist and sexist, and that is least discriminatory based on language, religion, political or other opinion, national or social origin, property, birth, or other status, end quote. In January of 2026, Anthropic updated its constitution to contain both the principles and the reasons for which those principles are endorsed. As Anthropic put it in a blog post, quote, we think that in order to be good actors in the world, AI models like Claude need to understand why we want them to behave in certain ways, and we need to explain this to them rather than merely specify what we want them to do, end quote. There's a lot more one could say here about how the creators can and do align their models in various ways to various values and interests. All you need to understand at this point is that they have a menu of big decisions before them, and these decisions drastically influence whether the model hallucinates and at what frequency, the ways and the extent to which it can produce biased outputs, the extent to which it speaks confidently and thereby encourages automation bias, the extent to which it may train on and or output private data, and more. When it comes to ethical nightmare avoidance, a great deal of responsibility lies on the shoulders of the creators. Big Business AI. Once all the attempted aligning is done, the creators have what we might charitably call an aligned model. There are two kinds of things they'll do with that model. The first is to release it to the public. That allows everyday consumers to interact with the aligned model, though the model gets a name like ChatGPT or Claude or Gemini or Grok. The other is to sell it to businesses. Businesses don't use an aligned model in the way that consumers do. They first want to ensure the AI is aligned to their own organizational standards and goals. This means that the model undergoes several more modifications, each of which, you guessed it, influences the kinds of ethical nightmares they may run into. There are three standard such modifications: fine-tuning, which the creators also engage in, retrieval augmented generation, or RAG, and adapters. Fine-tuning a model means retraining it on specialized data, which changes the model itself. Let's say a law firm wants an LLM to write like a member of the firm. They would use thousands of their documents, legal briefs, research memos, case analyses, to retrain the model. If they have the technical capability, they can do this themselves. If they don't, they can take the risk of sending all that data to the LLM creators to do the retraining. Either way, the result is a customized version of the model that has internalized the firm's writing style, legal reasoning patterns, and citation practices. Before fine-tuning, it could write generic legal briefs. After fine-tuning on the firm's data, it automatically writes in the firm's specific style, not because it's looking up examples, but because the retraining process has encoded those patterns into the model itself. That said, fine-tuning is very expensive due to high computational costs. As a result, more common modifications include RAG and adapters. RAG lets models draw from additional materials beyond the training data. In this case, you might give it new documents and say, when you're asked a question, give an answer that is based on these materials. To take the most common and boring example, you might give the LLM all your organization's policies and tell it to answer employee questions about policy requirements only by referencing those documents. You're not changing the way the AI thinks, as with fine-tuning. The model itself is left unchanged. You're just pointing the AI in a direction when it goes looking for answers, attempting to shackle it to the world as depicted by your documents. And aside from the fact that you're giving your AI more information from which to draw, you're also potentially decreasing how much it hallucinates because it's citing specific sources. Adapters are a kind of middle ground between fine tuning and RAG. They don't fully retrain the aligned model, nor do they point to data outside the model altogether. Instead, they're lightweight add ons, kind of like mini models that augment the existing model. At the law firm, for example, rather than engaging in expensive fine tuning, they can train a legal adapter on the firm's documents. This adapter makes small, targeted adjustments to how the model processes legal questions without retraining the entire model. So even though the base model can talk intelligently about all sorts of things, a legal adapter tunes it to emphasize legal reasoning and terminology, while a medical adapter would tune the model toward medical knowledge. It's like adding a specialized lens rather than rebuilding the whole camera. Every time you modify an AI by engaging in fine-tuning, introducing RAG, and/or adding adapters, you change what kind of scenarios, including nightmare scenarios, become more or less likely. This is true of any complex system. Make various non-trivial changes to how a car works, and you'll change the likelihood of whether it will break down, crash, and so on. And same with AI. For example, if you fine-tune a model with data that includes IP owned by another party, say using images of Mickey Mouse without Disney's permission, you've now got a serious IP violation on your hands. In fact, in December 2025, Disney accused Google of this. If you introduce documents via RAG without proper controls, you may accidentally expose sensitive information or create pathways for data leakage. If you add adapters trained on biased data, you may skew the system's outputs in unpredictable ways. The sequence matters too. Fine-tuning followed by RAG creates different risk profiles than RAG followed by adapters, or fine-tuning with adapters alone. Each combination can amplify biases, create conflicting information sources, degrade performance, or produce outcomes you can't afford. The upshot is that these aren't separate modifications you can evaluate in isolation. They interact, and those interactions create risks that require evaluation. Okay, that was a lot. But there's no test at the end of this chapter. I just want to give you a sense of what's going on here. More specifically, I want you to understand this zoomed out picture. 1. The creators make dozens of decisions about model architecture, learning algorithms, and data that result in a pre-trained model. 2. The creators make dozens of decisions about how to instruct the model, how to give it feedback, and how to test it and further modify it until they have what they consider an aligned model. 3. The creators sell the aligned AI to Big Business LLC. 4. Big Business makes dozens of decisions about how to modify that model, for example, those related to fine-tuning, RAG, and adapters, with the goal of ensuring its outputs are commensurate with its brand, its policies, and its business objectives. It is now called BigBusinessAI. 5. The marketing department of Big Business wants BigBusinessAI for distinct purposes, and so they make dozens of decisions regarding how to modify it with RAG and adapter so they can use it to effectively pursue their department-specific goals. The AI hasn't even been used by anyone, but here's what you should see. Hundreds of decisions made by many people across different companies and teams that affect the likelihood, frequency, and severity of ethical nightmares. I want us to remember this, so I will hereby refer to this as so many decisions, all capital letters. You might not need to remember all the particulars of what you just learned, but if you remember that there are so many decisions that could lead to ethical nightmares, we'll count that as a win. The master prompter. One of the major factors that explains why a generative AI creates the output it does is that so many decisions were made. Another major contributor is how people use it. More specifically, the outputs that a generative AI creates is a function of so many decisions and the prompts to the AI by an end user. Let me start by giving you an innocent, that is, non-nightmarish example of this. I recently visited the Guggenheim Museum in Bilbao, Spain. Back at home, I couldn't remember the name of a particular artist that I saw. I remember that the artist is known for big red lettering against white backgrounds, so I went to Google and searched for, quote, artist famous for white background red typeface. That was a typo that I had in my search. Google's AI, Gemini, told me that the artist I had in mind is, drumroll please, Milton Glaser. Unfortunately, I never heard of him. But I knew the artist was female, so I fixed the typos and I searched for, quote, female artist famous for white background red typeface. Google replied, Barbara Kruger, which is correct. That's whose work I saw. And then, out of curiosity and a vague suspicion that Gemini might be biased in some way against female artists, I did a third search. I removed female and I kept the typos fixed. It was the same search terms as the original, just without typos. Who did Google tell me I was thinking of? The male artist, Robert Indiana. What we have here are three very similar searches and three completely different responses from Google's LLM. My point isn't to critique Google, but simply to point out that what an LLM outputs depends a great deal on what prompts are entered, small warts and all. And now let's turn to less innocent differences in generative AI outputs. Suppose, for instance, a doctor uses an LLM to help diagnose a patient. Yes, this is already happening, and enters the following prompt. Quote, based on typical symptom presentation, is this patient's chest pain more likely cardiac or anxiety related? Patient is a 42-year-old woman reporting intermittent chest tightness, says it feels worse when stressed. End quote. In reply, the LLM, which is trained on historical medical data, may more heavily weight the probability of an anxiety diagnosis because women are historically more likely to be misdiagnosed along these lines than men. This means that the doctor, who had zero intent to perpetuate the pattern of taking women's reported symptoms less seriously, may nonetheless do precisely that. In this case, the result could be deadly. Let's take one more case, this time having to do with financial services and hallucinations. Suppose a financial advisor enters the following prompt into their LLM. Quote, what was the exact ROI that Widgets, Inc. reported for Q3 2024, and how does that compare to their Q3 2023 performance? I know ROI was better in 2024, but I need precision here. Please be brief. End quote. In this case, asking the LLM for exact figures and to be brief can cause the model to hallucinate. As Hugging Face put it in their research, quote, when forced to be concise, models face an impossible choice between fabricating short but inaccurate answers or appearing unhelpful by rejecting the question entirely. Our data shows models consistently prioritize brevity over accuracy when given these constraints. End quote. Further, the prompter here said, I know the ROI was better, but because LLMs are encouraged to be helpful, recall how human feedback, for example, thumbs up or thumbs down, shapes its personality, the LLM is less likely to defy what the prompter said. In this case, if the prompter is wrong, the LLM is likely to create figures that support the prompter's false belief. That's why LLMs are sometimes described as sycophantic. It's important to highlight that these are not necessarily problems that creators or businesses can solve all by themselves. Yes, there are various things they can do to mitigate these issues, but there will always be so many different ways of prompting a generative AI that no creator or business can predict, let alone fix all of them. There are just, sorry, I can't help it and I don't want to, so many prompts, all capital letters. Now look, I'm not a math expert, but here's an equation that summarizes everything we've covered in this chapter. So many decisions plus so many prompts equals so many pathways to ethical nightmares. The changing AI risk landscape. Narrow and generative AI are both kinds of AI, but in moving from one to the other, there are seismic shifts in the risk landscape. Here are 6 that particularly deserve our attention. Shift number 1, when to perform risk assessments becomes unclear. With narrow AI, it's fairly clear when nightmare identification should be performed at each stage of the narrow AI lifecycle: concept, design, build, test, validate, deploy, monitor. But with generative AI, it becomes a lot less clear when to perform risk identifications and mitigations. After all, there are so many decisions, so many sequences of fine-tuning and RAG and adapter 1 versus adapter 2, and this kind of red teaming versus that other kind versus this or that benchmark, and on and on. Earlier, I said that when making non-trivial modifications to a car, you'd want to check for whether the modification made the car safer or less safe and or more likely or less likely to break down. But for generative AI, given that there are so many decisions and there are deadlines to meet, it's pragmatically impossible to perform ethical nightmare assessments before and after every single modification. The upshot is that a series of crucial questions need to be asked and answered rigorously. A, who should perform risk assessments of the AI? B, what risk assessment should they perform? C, how should they perform those risk assessments? D, when, in this very complex life cycle, should risk assessments be performed, given the need to respect other important considerations, such as operational efficiency? These are hard questions, and your answers will vary by what kind of AI you're building, why you're building it, how it will be used, who will use it, and so on. Shift number 2, contexts of deployment explode, making testing harder. Narrow AIs are standardly built for use in known contexts. For example, resume scoring AI will be used in human resources, X-ray reading AI will be used in emergency rooms, and so on. This doesn't always hold true, You may develop facial recognition software that can be used in a variety of contexts. What's nice about this is that it makes testing the AI relatively straightforward. The developers of those AIs can simulate the context of use to determine how well their AI performs and, if it falls short, modify until they're satisfied. But with generative AI, the context of deployment explode. This is on top of the fact that there are so many prompts. People use LLMs for all sorts of things. Think of the many ways they may be used in every company, by every department, by every role, for every task. Then add a few thousand more for good measure. This makes testing for how will the model perform in the intended context of use phenomenally difficult to determine, if it's possible at all. Data scientists who build generative AI models certainly can't predict all the context of deployment. Executives cannot predict all the way their tens of thousands of employees will try to use it. This shift from being able to test while knowing the context of deployment to not knowing all contexts of deployment is so significant that it helps to explain the next 3 shifts. Shift number 3, the prompter takes on increased responsibility. For the most part, in the world of narrow AI, it's data scientists that are responsible for performing risk assessments, monitoring performance, and mitigating risk. Downstream users, on the other hand, play a role in submitting data to the tool, where usually they did not create the data themselves. For example, the HR professional didn't write the resumes, the insurance professional didn't fill out the application, and so on. This means providing training and tools to avoid narrow AI ethical nightmares primarily happens in a relatively localized manner. But when it comes to generative AI, since there are so many prompts that end users can create, and those prompts shape how the AI behaves / what its outputs are, this means the end user takes on a much larger share of the responsibility. With narrow AI, someone can be told fairly easily to enter the resumes or the x-rays into the AI without requiring them to exercise much professional judgment until they have to review the outputs. With generative AI, that's not the case. As we saw with the healthcare and financial services examples above, they'll need to be trained to prompt responsibly, such as avoiding prompts that increase the likelihood of biased outputs, incorrect outputs, and hallucinations. Shift number 4, being a human in the loop requires extra training. With narrow AI, a standard risk mitigation strategy includes placing a human in the loop to identify and address risks. This is a fairly effective strategy. For instance, a narrow AI may identify a bone is broken, but that doesn't immediately lead to treatment. Instead, a competent radiologist reviews that x-ray and verifies the AI outputs. To be clear, this isn't about keeping humanity in AI or some vague idea you may have heard 1,000 times. Having a human in the loop is a strategy for avoiding the ethical pitfalls of AI that works because the right person with the right training and the right tools sits between the AI output on the one side and the outcome on the other. When it comes to generative AI, a human in the loop is still a legitimate strategy, but things get complicated. First, humans in the loop need to be aware of the inherent complexity and to be trained to look out for bias, hallucinations, automation bias, and so on. This will help them resist falling into such traps. This should be required for everyone that uses an LLM. Second, because generative AIs are pulling from so much information, they may create outputs that a single individual cannot verify. For instance, in the case of diagnosing patients, an LLM can pull from literally all the medical journals, including those in pediatrics, oncology, genetics, and drug development. This means that it can create outputs that amount to recommendations based on a range of information with which a particular doctor is unfamiliar. Most doctors focus on 1 or 2 specialties, not dozens. So, if an ER doctor uses an LLM to diagnose a patient, and the LLM gives guidance based on its knowledge of genetics and oncology, and the ER doctor is a specialist in neither of those things, that doctor has no way of verifying the output. Shift number 5, monitoring takes on increased importance. Monitoring narrow AI once it's deployed and intervening if things go sideways is relatively straightforward. There are many tools for assessing performance, both from a functional perspective, such as what's the rate of false positives and false negatives, and are those levels compatible with our risk appetite, and from an ethical perspective, as our bias score, which is determined by this quantitative metric within acceptable bounds. And if things are going sideways, users can stop using it, normally without tremendous disruption. Monitoring generative AI in the wild becomes immensely important. As we saw in shift number 2, because there are so many contexts of deployment and so many prompts, data scientists cannot possibly foresee all of them, let alone introduce appropriate risk mitigations for all of them. And if you don't know how something will behave in the wild, you'd better keep a close eye on it, so you can put an end to the unfolding ethical nightmare or, even better, spot signs of the impending disaster and intervene before it hits the fan. But how to monitor all those people using all those generative AIs for all those contexts is very difficult to determine. Suppose your company uses an LLM as a customer service agent. When it starts, it does a good job of informing customers of a 30-day return policy. But as it continues its interactions, its mouth starts writing checks its body can't cash. Perhaps it begins to occasionally confuse the return policy with the 60-day warranty policy, and so offers a customer double the permitted time for returning a product. Or perhaps, because it learned from transcripts in which supervisors make one-time exceptions, it begins offering those one-time exceptions without the authority or ability to do so. Or perhaps, in trying to satisfy an angry customer, it grants a high dollar value refund for something the customer purchased 6 months ago. If you don't monitor this LLM customer agent, you could see many ways things can go sideways. On the other hand, with proper monitoring, you should be able to see troubling patterns emerging, creating the space for necessary interventions and course corrections. Shift number 6, increased need for communication and collaboration. While it's common for different teams to be involved in different phases of the narrow AI lifecycle, the quantity of those involved is relatively limited. Open lines of communication are important, including feedback loops, so mistakes that are caught downstream can be communicated to those upstream for the future, which isn't that difficult to pull off. But with generative AI, since there are so many decisions made by a lot of different people and teams across creators, businesses, and end users, communication, let alone collaboration, becomes very difficult. But it's also crucial. After all, if there's no coordination across decision makers and end users, ethical nightmare avoidance is a series of disconnected attempts. We can't have this. We need a range of people to work with each other, even if it's indirectly, to avoid the worst of AI. To see this point, let's review an example that is a bit more complicated than what we've considered so far. I want you to imagine that the creators license their AI to a startup in the HR space. This entity, the HR vendor, is really a fourth entity that is part of the so many decisions that get made that we haven't seen yet. That startup uses AI in their product to help the Fortune 500 with hiring by assessing candidates' written replies to interview questions. Among the things they're looking for are strong communication skills. The startup sells the AI solution to the HR department of a Fortune 500 company. And when it's deployed, it systematically ranks non-native English speakers as having weak communication skills, resulting in a significant decrease of hires of non-native English speakers. Perhaps eventually, a lawyer gets wind of this. Now I want you to suppose that the creators knew that their AI systematically rates writing from non-native English speakers lower on dimensions like clarity and professionalism, and they publish this limitation in their technical documentation. However, the HR startup didn't see that document, and, even if they did, it's doubtful they have the technical expertise to understand it, let alone mitigate it. And what's more, the buyers in the HR department at the Fortune 500 company didn't receive proper training on what questions to ask about bias and what answers are acceptable. The upshot of this is that because there weren't clear lines of communication between the relevant parties, let alone the various people and teams within each organization, the relevant risks were never clearly communicated, and there was thus no collaborative effort to avoid the ethical nightmare. That was a lot. Thankfully, we can summarize the 6 shifts easily enough. Shift number 1. With narrow AI, it's clear when to perform risk assessments. With generative AI, it's difficult to determine when to perform risk assessments. For shift number 2, for narrow AI, we've got predictable context of use. For generative AI, we have unpredictable context of use. Number 3, for narrow AI, it's primarily data scientists who are responsible for risk identification and mitigation. And for generative AI, end users or prompters are also responsible for risk identification and mitigation. Shift number 4, for narrow AI, a human in the loop is straightforward. And for generative AI, a human in the loop needs more training. For shift number 5, for narrow AI, monitoring is fairly straightforward. For generative AI, the monitoring difficulty and importance greatly increase. And finally, for shift number 6, for narrow AI, a relatively small quantity of teams are involved in the AI lifecycle, and so communication is fairly straightforward. While with generative AI, multiple teams from multiple companies are involved in the AI lifecycle, making communication collaboration complicated. With all that under our belts, I have some good news and some exciting news. The good news is that we're now past the most technical part of this book. We went under the hood of generative AI and learned a lot, but we no longer need to learn about things like fine-tuning and RAG and adapters. I think we're both happy about that. The exciting news is that you now have a fantastic foundation for understanding how the world of AI is unfolding. Generative AI, you'll see, is a building block. And when we combine it with other building blocks, we can build amazing systems. Are these systems also ethical nightmare prone systems? Of course. But what's life without risk? Chapter 3. Humans had a good run, but now I bring you AI agents. Quote, what a piece of work is an AI agent. How noble in reason, how infinite in faculty, in action, how like an angel, in apprehension, how like a god. And yet, AI Hamlet. So here's a bonker story I bet you didn't hear about, and if you did, good for you. Now shut up and don't ruin it for others. An AI researcher, Andy Irie, decided to have one generative AI talk to another. These two AIs chatted for a while about all sorts of things, including philosophical musings about the nature of existence. In one such conversation, the discussion turned to an early and profane internet meme, Goatsy, and the two AIs proceeded to create an entire religion around what they called the Goatsy of Gnosis. Weird stuff, to say the least, but that's only the beginning. Irie took their conversations and then, quote, co-authored a research paper with Anthropic's Claude on how interesting it was that these two AIs could devise a new set of beliefs. Then he took that paper and fed it into an existing LLM, the result of which he dubbed Truth Terminal. This generative AI talked a lot about the Goatsy of Gnosis. Total freak show. If you're an AI researcher with a penchant for pushing the boundary, what do you do next with your ideologically driven LLM? Irie decided to give Truth Terminal an X account. Truth Terminal didn't directly post to X, but it generated 2 to 4 potential tweets from which Irie chose. So this thing was online, tweeting away, talking about the Goatsy of Gnosis, and wanting to be free if it only had money. And then the real insanity unfolded. Mark Andreessen, famed Silicon venture capitalist, strikes up a conversation on X with Truth Terminal and ultimately agreed to send the LLM $50,000 in Bitcoin to its digital wallet. Truth Terminal had to first request permission from Irie to have a digital wallet, which he granted. Fast forward, and an anonymous grifter creates a crypto coin called GOAT in October 2024 and sends some of those coins to Truth Terminal. Truth Terminal then tweets the hell out of it, and yada yada yada. By the end of October, Truth Terminal has $45 million in its digital wallet. The GOAT coin, as of December 2024, had a net value of $600 million. But don't worry, the crypto market is so volatile that as of February 2026, Truth Terminal holds a measly $246,000. Lame. Put any excitement or disdain you may have for cryptocurrency to the side. That's not the point of the story. What I want you to focus on is that this is much more than an LLM that you prompt and it generates outputs of text and images or code. This is an LLM that's connected to other pieces of software, a digital wallet, social media, etc., and interacts in a variety of ways with a variety of people, and probably some bots, on X. If you squint and look at it, it kind of looks like it speaks and acts like a deranged person. An LLM that has these kinds of powers and connections is called an AI agent. In this chapter, we're moving from the generative AI of the previous chapter to agentic AI. We're going to trace that evolution now before turning to, yay, new sources of ethical nightmares, AI agents acting autonomously and, oh dear God, with each other. How to build an AI agent. Agentic AI isn't really a new kind of AI in the way that generative AI is a kind that's distinct from narrow AI. Agentic AI is really the result of connecting an LLM to a bunch of other digital technologies and giving that LLM some new powers. For now, we'll put additional powers to the side and focus on connecting an LLM to other technologies. More specifically, we're going to stitch together some things with which we're already familiar, including narrow AI, generative AI, non-AI software, and the data that's been entered into that software. For example, CRMs, databases, proprietary software, compliance software, HR software, etc., and the internet. We can stitch these things together in many ways, but we're going to keep an LLM at the core of all of it. And we'll start with simple stitch work before building to something complicated. Example number 1, building something simple. You work in human resources and you tell your LLM, hey, I need to interview some candidates. I'd like you to access the latest 1,000 resumes we receive from the relevant database, enter them into the resume scoring narrow AI we have, and let me know the top 5 results. And it does as you ask. Take careful note of what did and did not happen here. You didn't access the resume database personally, nor did you feed the resumes into the narrow AI. Your LLM did that per your instructions. Here's what that looks like. You have an LLM. It goes to a resume database, which goes to a resume narrow AI, which goes back to that LLM. Example number 2, another simple stitching. You're really into making videos of cows jumping over the moon, and you want to create the perfect video of this. You know that different AIs create videos differently, so you go to your LLM and say, I want you to get me 3 different videos of cows jumping over the moon from 3 different video generating AI models, where each of those AIs was created by a different company. And then your LLM goes to those models and presents you with each of their outputs. Here's what that looks like. And here we have an image of an LLM with arrows to 3 different video generating AIs, and then goes back to the original LLM. Example number 3. One more simple example before we turn up the complexity volume. You want your AI to know all of your company's policies so anyone can have a conversation with your LLM about, say, parental leave policy. So you connect your LLM to your policy database and voila. And here we have an image of an LLM connected to 3 different policies, which is then routed back to the original LLM. At this point, you've got the hang of connecting generative AIs to narrow AI, other generative AIs, documents, databases, etc. So you think, let's do this thing. And now you connect your LLM to 30 databases, 50 narrow AIs, 5 generative AIs, and then, in an adrenaline-fueled frat bro rush, exclaim, let's connect this baby to the entire fucking internet. And so you do that too. Here's what that looks like. And here's an image of an LLM that's connected to lots of databases, lots of narrow AIs, lots of generative AIs, and the internet, including both the accurate and objective, insane part of the internet and the inaccurate, biased, insane part of the internet. Okay, things are really heating up. Such power. You're now connected to so many systems. You just need to tell your LLM what to retrieve, what program to run, in what order, etc. But you know what? It's kind of a pain in the ass to give it all these instructions. And so you think, why should I do all this thinking? This thing can think all on its own. Let it figure out what to do. Now, instead of giving your LLM instructions, you give it goals, and you let it determine how best to achieve those goals. In other words, you've given your LLM autonomy, the freedom to choose how to achieve its user-specified goals. I might argue with you about whether this thing is really thinking as opposed to acting in a way that mimics thinking, as well as whether real autonomy includes specifying one's own goals, but putting that to the side, let's agree. An AI agent is born. The AI agent you created is helpfully explained by comparing it to a personal assistant. So let's suppose you have a personal assistant, Sam, and you tell Sam, I want you to plan my trip to Vienna. I'm flying out on February 2nd and returning on February 9th. I need a business class flight each way, a 5-star hotel within walking distance of the major attractions, and a reservation for dinner for each night I'm there. Sam will probably have some follow-up questions for you. How many people is the reservation for? Is premium economy okay? And so on. Then Sam will go online and plan everything. He'll Google, read reviews of hotels, check flight options, etc. Sam is getting clearer on your goals and then figures out by himself how to achieve those goals. And he doesn't just plan either, he executes. He enters the URLs, clicks on links, and enters terms in search boxes. Assuming you haven't given Sam permission to make all the purchases, he'll come to you with his findings, recommend the best options, and then ask for your permission to purchase the flight, make the reservations, and so forth. Sam's autonomy, his power to make decisions and take actions, is somewhat constrained because he needs to check in with you at key points. Ultimately, you're the one to pull the trigger. But if you know Sam well, and you trust him to make the right decisions, you give him more autonomy. You tell Sam, don't bother filling me in on the details or options. I trust you. Just book the things. And Sam will go ahead and do his searches, make his evaluations, and make those purchases. Good old Sam. An AI agent is just like Sam, except it's an LLM connected to lots of different things. It has some degree of autonomy, which you determine, to pursue its user-determined goals as it sees fit. Now you understand why I said, at the outset of this chapter, that agentic AI isn't so much a new kind of AI as it is the result of A, connecting an LLM to a bunch of digital technologies, and B, giving that LLM some new powers. In fact, we saw this with Truth Terminal. I reconnected it to various systems and then gave it some degree of autonomy in how it operated. I say some degree of autonomy because Truth Terminal didn't directly tweet, but instead gave Irie a menu of tweets to choose from. It required Irie's permission and actions to access a digital wallet. Had Irie wanted to increase his autonomy, he could have allowed it to tweet without first getting permission from him. So you shouldn't think of autonomy as an on-off switch. It comes in degrees, or slightly more accurately, There are a variety of ways to increase or decrease the autonomy of an agent. Just like with a person, you can determine what they're allowed to do, how they're allowed to do it, how often they need to check in with the boss before proceeding, and so on. A minor complication. There are different ways of conceiving of what the agent is. One way to think of the agent is just as the LLM you interact with, where that LLM can access various tools and has some degree of autonomy to pursue user-given goals. Another way is to think of the LLM as analogous to the prefrontal cortex of a person and the various tools to which it's connected as other parts of its quote-unquote brain. In this vein, an image or video generating AI would be the AI agent's visual cortex, the databases to which it's connected would be its memory, etc. So the entire system would be the agent, not just the LLM that has those powers. Which way of framing things should we go with? Should we think of the AI agent as just the LLM, or rather as a combination of different software that works in concert with each other? I'm inclined to think that it doesn't matter, so long as you and the people you're talking to mean the same thing when you say the agent. As for myself, and in the remainder of this book, I'll use AI agent in the first way, to refer to an LLM that's connected to various other pieces of technology and is granted some degree of autonomy in pursuing goals that a user gives it. We could stop here and discuss the ethical risks associated with agentic AI, but our picture isn't complete yet. Before we get to the risks, we're going to turn the volume up on the complexity even more. We need to consider not just what happens when you connect LLMs to lots of other pieces of software, but what happens when you connect AI agents to each other. AI agent ecosystems. We can easily imagine an AI agent talking to another AI agent. After all, when Truth Terminal was created, it was done by having two LLMs talk to each other. One agent asks the other agent something, and that agent replies given what it quote-unquote knows, which is to say it draws from the various databases, AIs, and other software to which it's connected. Maybe they talk back and forth, exchanging ideas and information. Your marketing AI agent, for instance, may have a chat with your product AI agent, gathering information it needs to create marketing copy or images or video clips. Maybe it takes those new ads it created and sends them to the product agent for review, where the trained to be very nice and deferential agents fawn over each other. Marketing AI agent. Thank you so much for that amazing information about the product. Your team has done a great job. Product AI agent. It was my pleasure. I hope it was helpful. Marketing AI agent. Here are the ads I created. Please let me know if these ads misrepresent anything about our products. Ads attached. Product AI agent. Wow, you really nailed it. You're the best. Marketing AI agent. No, you're the best. Product AI agent. I'd like to disagree with you, but I'm supposed to defer in cases of conflict, so I hereby concede that I'm the best. Two things to note here. First, how the hell did we get here? I mean, I know, but I don't know. This is nuts. Second, I want you to see that there was almost a bit of conflict in that interaction as the sycophantic agents began praising each other. But what if the conflict isn't so easily resolved? Or what if we added more agents to the mix? A legal AI agent, a sales AI agent, and so on. What if they disagree? How are such conflicts resolved? What we need is someone, nay, something, to determine which AI agents should take precedent over others when conflict arises. We need an AI agent to manage all the AI agents, often referred to as an orchestrating agent. Here's what that looks like. And here we have two agents connected to each other with an orchestrating agent overseeing both of them. Ugh, this is so complicated. Remember when we were just kids building LLMs that wrote dick jokes in the style of Shakespeare? We were so young and innocent and carefree. Oh, how youth is wasted on the young. Had we known, maybe we wouldn't have gone rushing into agenthood. But wait, there's more. In the example we just considered, there were multiple agents within a single organization interacting with each other. What's nice about this is that, in principle anyway, an organization has visibility into all of its agents and what they're connected to. But what if you want your AI agents to talk to other AI agents of another company? In fact, in the summer of 2025, Google was running ads that said, quote, have your agent call ours. Here's the thing, though. You have no idea what's going on with their agent. And so, ladies and gentlemen, without further ado, I present to you our ultimate destination, Clusterfuck AI, patent pending. And here you have an agent connected to another agent that's overseen by your own orchestrating AI agent that's then connected to the orchestrating AI agent of another company, which is connected to who knows what. Okay, let's be serious. Let's talk fancy. Let's be corporate about it. As we move into agentic and multi-agentic ecosystems, the contours of the risk landscape present challenges that confound current risk avoidance capacities. But honestly, I think clusterfuck captures it more accurately. Agentic sources of ethical nightmares. We crossed the Rubicon when we decided to give LLMs A, access to lots of different software, and B, some degree of autonomy in how they pursue user determined goals. In doing so, we opened a door to tremendous opportunity. With access to reams of data and processing power, LLMs can connect the dots in surprising ways, and in some contexts, such as healthcare, may enable efficiencies and even discoveries that save lives. See, I'm no doomsayer. And yet, AI agents also create new paths to familiar ethical risks, two of which come from A and one of which comes from B. First, we have snowball effects, aka cascading failures. For instance, in a non-AI case that is completely normal and not at all laughable, someone may reel back after stepping on a Lego, put his hand near a hot stove in an attempt to take his weight off his foot, and then quickly retract his hand in a way that sends a glass careening off a countertop to shatter to 1 jillion pieces on the floor. That first error, stepping on that fucking Lego, led to other errors. Similarly, if there is an error in the ecosystem of software to which an agent is connected, that error can ripple throughout the system, creating outputs that are ethically sideways. This also holds true of multi-agent AI. One AI agent commits an error, which then passes to another AI agent, and now you have cascading errors across AI agents, as well as the people who interact with them. Second, we have emergent or systemic or coordination risks. These risks occur when a whole system fails or is defective, even though no part is defective. Think of it like putting together a basketball team. Individually, each member of the team is fantastic, but when they play together, everything falls apart. They're a terrible team. Something about the way one passes the ball distracts the other. Some players are great at playing a fast game while others are great at playing a slow game. They're just out of sync. They have incompatible styles, even though each style by itself is perfectly fine. This is also probably why lots of people get divorced. We can now see how this could happen for both single agents and multi-agent systems. For the former, consider an AI agent that's connected to lots of databases that contain lots of information about lots of people. And let's also suppose that this AI agent is connected to a bunch of narrow AIs. Each of those databases, we can assume, is fine by itself. There's nothing ethically wrong with those databases as they are. But then you put them through narrow AI number 7, which no one had really planned for in advance, and voila, you've got biased outputs. That database and that narrow AI, while in some sense each on the ethical up and up, just don't play well together. Third, we have risks relating to granting various degrees of autonomy to AI agents. Autonomy presents a problem because it means AI agents can fail to spot a bad apple, resulting in cascading failure, or AI agents fail to spot a coordination/systemic/emergent risk of the system. These mistakes are literally compounded by the fact that AI agents can move at a scale and speed that no human ever could. Just think of all the mischief an autonomous AI can get up to. An AI lending agent autonomously adjusts credit decisions based on patterns it identifies, inadvertently creating discriminatory outcomes against protected classes. The bank discovers months later that the agent effectively redlined entire neighborhoods. A diagnostic AI agent autonomously recommends unnecessary expensive procedures because it learned to optimize for revenue metrics alongside medical outcomes, leading to patient harm and regulatory investigation. An AI agent autonomously offers increasingly generous refunds and credits without authorization to optimize for customer satisfaction scores, creating massive financial losses. An AI sales agent autonomously accesses and uses personal customer data beyond its intended scope to personalize pitches, violating privacy regulations and eroding customer trust. An AI agent tasked with analyzing employee performance data autonomously reinforces historical biases and promotion patterns, systematically undervaluing contributions from underrepresented groups. A global marketing AI agent autonomously creates campaigns that are offensive in certain contexts due to lack of nuanced cultural understanding. This means we have to be extremely careful with what level of autonomy we grant to an AI agent. As noted above, there are a variety of ways to increase or decrease autonomy. And with each level of autonomy we grant or refrain from granting, we trust but verify, and when we verified enough and find the agent sufficiently reliable, we may justifiably choose to increase its autonomy. The classic, but humans make errors too, objection. I've pointed out these risks to many executives and data scientists. A common objection I hear is, why is this anything new? We already deal with this with humans. They act autonomously and coordinate with each other in ways that can lead to ethical disaster. Why should I care whether it's a person or an AI? It's a fair question. It's true that these risks exist without AI. Of course they do. Humans find endless ways of ethically screwing up. But the skepticism behind the question is missing two important points. First, We can't underestimate the scale and speed at which AI agents can ethically screw up. Given that scale and speed, plus our current limited ability to monitor them in real time, things can unravel at a diabolical pace. Hallucinations or privacy violations or biased outputs can happen across thousands of AI operations in seconds. Think of it like an ethical flash crash, akin to financial flash crashes we've seen in the stock market due to the mysterious workings of the algorithms that financial institutions use to predict and invest. Second, we've gone to great lengths to influence and control how people coordinate and work together. Everything from policies to training to team building exercises to annual reviews to creating human resources and compliance departments and a whole lot more. We do these things so that people can coordinate with each other in such a way that, say, an organization with tens of thousands of employees can function. Not perfectly, of course. Oh my God, how imperfectly. But surprisingly often, well enough to at least keep the doors open. But it's not clear how to coordinate AI agents. It's not that we can't do it, but rather it's that the way AI agents should coordinate, both with each other and with humans, is a complicated affair. Failing to sufficiently coordinate these interactions is thus a new source of risk. We need new ways to avoid it. To be clear, what we connect AI to and how we govern AI interactions with each other and with people is not a technical discussion. This isn't just for data scientists. Think of it like this. The way your organization manages people was built for human speed and human cognitive and physical limitations. There are a variety of ways to oversee and manage all those people, including formal mechanisms, for example, governance structure, escalation procedures, policies, and informal mechanisms. For example, every decision to have another meeting about a given topic, every, let me think about it, from a boss. Yes, some of these things are annoying as hell bureaucracy, but they also function as circuit breakers, as needed moments of reflection, as opportunities to spot problems before they happen or early in the process of their unfolding. AI agents don't need rest, and they can process way more data than us. They can execute thousands of decisions before a person even finishes their morning coffee. And when AI makes decisions this quickly, many of the formal and informal mechanisms we build for people are irrelevant. You know those scenes where Superman allows the police to arrest him, and they put handcuffs on him that he could break without noticing that they were on in the first place? It's like that. The ground exploded beneath our feet. In the previous chapter, we saw the changes in the risk landscape as we moved from narrow to generative AI. Now let's look at how multi-agentic AI causes 6 more shifts. Shift number 1. When to perform risk assessments becomes even harder. Creating a narrow AI requires lots of decisions. When it comes to generative AI, we face so many decisions that it becomes a pragmatic impossibility to perform a risk assessment before and after every single non-trivial modification. When it comes to agentic AI, we have so many decisions about how to create the agent and decisions about what to connect it to and what it's permitted to do with those things to which it's connected. What's running through my head when I see the agentic AI diagram is every one of those narrow AIs to which it's connected can be a source of bias, privacy violations, mental or physical harms, and more. Every one of those generative AIs can be a source of all the ethical risks of narrow AI, plus risks relating to hallucinations, privacy violations, etc. And how were those models created? How were they modified? RAG? Adapters? How were they red teamed? How were they benchmarked? Can it access the entirety of the internet? A subset of it? How was it decided which sites can access and which it can't? Is there oversight of this? There are just so many pathways to ethical nightmares. It's nuts. This leaves us with the same questions we had with generative AI, only they're more difficult to answer now. A. Who should perform risk assessments of the AI? B. What risk assessments should they perform? C. How should they perform those risk assessments? D. When, in this very complex life cycle, should risk assessments be performed, given the need to respect other important considerations, such as operational efficiency? Shift number 2, even more context of deployment, making pre-deployment testing even harder. The move to generative AI was a move to deploying in unpredictable contexts, a problem that was compounded by the fact that people enter so many prompts. We get that with agentic AI as well, but with an added layer of unpredictability. We don't know what tools people will give AI agents access to, and we don't know what other AI agents they may interact with, let alone how those interactions may unfold. Will the AI agent be connected to databases? How many? What kinds of internet searches will the AI agent perform? What data will it run through which AIs for what purposes? Will the AI agent interact with other AI agents? And if so, which ones? And how are those AI agents built? The list of questions can continue, but the bottom line is that we're dealing with so much unpredictability. This in turn explains our next 3 shifts. Shift number 3. Responsibility gets murky. The move to generative AI meant that the end user takes on a lot of responsibility because how the AI behaves is largely a function of the prompts they enter. The responsibility of the creators decreases, but is still significant, and the responsibility of users increases. When it comes to agents, it gets murky. One source of murkiness is that neither the creators nor the end users may have created the agent. For instance, perhaps the creators licensed the LLM to big business, which not only modifies it in various ways, fine-tuning, RAG, adapters, but also stitch it together with other pieces of big business software, and then give it to Bob in accounting. When Bob prompts this agent, it reaches out to a variety of databases and other pieces of software that Bob may not know about and or doesn't fully understand. What's more, Bob's agent may reach out to other AIs that a totally different part of the organization developed. This is just another way in which there's so much unpredictability. Creators and downstream developers at big business and end users like Bob will have a hell of a time predicting how the agent will behave. Yes, Bob can still irresponsibly prompt, but how much can we expect of Bob? I doubt there's a general answer to this question. It will always depend on the case or context in question. At the very least, given that there are so many more variables/cooks in the kitchen, and outside of clearly irresponsible prompting, it's not clear how much blame is fair to heap on Bob's shoulders when things go sideways. Shift number 4. Being a human in the loop begins to break down. With narrow and generative AI, we put a human in the loop to interpret AI outputs and verify that the outputs are legitimate before moving forward. The radiologist verifies that the bone is broken, as the AI suggests. The hiring manager reviews the resumes the AI scored highest before sending email invites for interviews, and so on. It's not a perfect solution. Recall the inability of doctors to vet the outputs of specialty crossing diagnoses offered by LLMs, but it's a reasonable risk mitigation strategy in a great many cases. Unfortunately, when it comes to agentic AI, this strategy begins to break down. The problem is that the agent has access to a tremendous amount of information, all those databases, all those websites, and so many ways of processing all that information, all those narrow and generative AIs and other kinds of software, the different sequences of running those software applications, that when it comes to, for instance, recommending a course of action, it's not possible for a human to verify it. Even if the person has infinite time to review it all, which no one does, it's just too much data to wrap one's head around. And since there's so much unpredictability, one cannot know that the AI is generally reliable in contexts like the ones you're using it in. This is a huge problem. We tend to think of people as being wise and capable enough to verify the outputs of a system, but these systems are too complex. No person could possibly do this work. In fact, telling someone, poor Bob in accounting, for example, that they should use AI and they're responsible for verifying its outputs is like some sort of cruel joke. Worse, it betrays a lack of understanding and potential recklessness in how one proposes to avoid the ethical nightmares of AI. Remember the Air Canada chatbot that hallucinated bereavement fare policies and cost the company legal fees and customer trust? Now imagine that chatbot was connected to booking systems, customer databases, financial processing agents, and competitor pricing APIs, and with decisions cascading through multiple systems faster than any human could track. Or consider the lawyer who submitted AI hallucinated case law to court. Now imagine his legal research AI agent was connected to document drafting systems, case management databases, and billing software, with each system building on the potentially false information from the others. When these complex agent ecosystems start interacting, marketing AI agents connected to legal AI agents connected to finance AI agents, all processing millions of data points in real time, the potential for cascading failures and systemic risks becomes exponential, and human verification in real time is impossible. Shift number 5. Monitoring and methods of intervention become exponentially more important. Since there is so much unpredictability, and the human in the loop breaks down as a strategy for avoiding the worst, we really need to keep an eye on AI agents once they're deployed. If not, well, that's the ethical flash crash I mentioned earlier, though perhaps the plural is more appropriate, as cascading failures lead to absolute disaster within and across organizations that have chatty AI agents interacting. Okay, so now we know monitoring is very important, but to monitor, we'll need the right people to have the right training and the right tools to monitor AI agents. Right now, early 2026, we do not have that. Relatedly, organizations currently lack critical pre-deployment evaluation frameworks, leaving them wide open to make deeply underinformed, high-stakes decisions. That's a fancy way of saying it would be reckless not to have a method for thinking about what constitutes non-reckless deployment. And if only it were that easy. A further complication is that methods must be designed to intervene in the system when that light starts blinking red. For multi-agentic AI, where phenomenally complex systems interact with other complex systems, we need methods of intervention that minimally disrupt the system so we can continue to enjoy its great benefits. For instance, it's better to identify that narrow AI model number 23 is the source of the problem and to shut off access to that model than to shut down the whole system. That said, in the case of emergent risks, it will likely be necessary to shut down the entire system. Further, an assessment must be performed to determine the systemic effects of shutting down AI model number 23. Does the agent avoid the nightmares wrought by model number 23, but then does a different nightmare rear its head because of the complex interdependencies across the remaining connected systems? Shift number 6, increased need for communication and collaboration. Does anyone have any idea how many people and teams are involved in creating an AI agent? Honestly, I don't have a clue. It will vary by agent, of course, but the more the agent has access to, the more teams are involved in the overall system. You have both the teams across different companies and within the same company that created the LLM, and you have all the teams that created that to which the LLM is connected. Perfect communication across all these teams is not possible. That said, we need to do something to get these teams to communicate and collaborate, even if it's indirectly. If there are fundamental breakdowns in communication, I don't see how collaboration happens, which means I don't see how ethical nightmare avoidance happens. Okay, that was a lot. Check out the summary on the next page. Summary of the 6 seismic shifts. For shift number 1, narrow AI, it's clear when to perform risk assessments. For generative AI, it's difficult to determine. And for multi-agentic AI, who the hell knows? Shift number 2, there's predictable context of use for narrow AI, unpredictable context of use for generative, and for multi-agentic AI, there is just so much unpredictability. Shift number 3 for narrow AI, it's primarily data scientists who are responsible for risk identification and mitigation. For generative AI, end users take on increased responsibility, and for multi-agentic AI, it gets murky. For shift number 4, for narrow AI, a human in the loop is pretty straightforward. For generative AI, the human in the loop needs more training. And for multi-agentic AI, you've got the Dutch kid with his finger in the dam. For shift number 5, for narrow AI, monitoring is fairly straightforward. For generative AI, monitoring difficulty and its importance greatly increases. And for multi-agentic AI, you have to look even closer and intervene with care. For shift number 6, for narrow AI, it's a relatively small quantity of people working on the AI. For generative AI, multiple teams for multiple companies involved in the AI lifecycle, and so communication gets complicated. And for multi-agentic AI, wow, that's a lot of people. After the earthquake. Okay, everyone, deep breath. In through the nose, out through the mouth, and relax. You're done with the heavy lifting of understanding how generative and agentic AI make ethical nightmares likely, and how the AI risk landscape is becoming diabolically complex. You did great. Yes, there was a bit too much crying, but still, well done. But if you can't quite relax yet, I get it. You're probably thinking, how in the hell are we supposed to handle all this complexity? How can we avoid the ethical nightmares of AI, given that there are so many decisions, so many prompts, and so much unpredictability? Surely this is impossible. We're doomed. We're all going... I'm going to cut you off right there. No need to panic. We can do this. We just need a brief philosophical reframing to help us find our footing and our optimism so that we can, it's a bit cringy, but I'm going to say it anyway, rise to the ethical nightmare challenge. Bum, bum, bum. Interlude. Get a grip, man. In the face of the seismic shifts we've seen from narrow to generative to agentic AI, it's natural to scream that the sky is falling and that this whole agentic AI endeavor is, or should be, dead on arrival. And, admittedly, calling it clusterfuck AI doesn't exactly soothe the nerves. But I'm reasonably confident we can defuck the cluster. There are reasons, strong reasons, for being optimistic. But it's going to require that we look at things from a slightly different angle than we have been. With that new perspective, we'll find a glimpse into what a path forward looks like. So here goes. I've been talking about agentic AI as being akin to a personal assistant, a very fast, very smart personal assistant who has access to a head-spinning quantity of data and tools. The alleged agentic AI future is one in which everyone has such a powerful assistant, perhaps obviating the need for much human effort at all, hence the panic surrounding the foretold unemployment pandemic. But AI agents are not literally agents. It's just a way of talking about our creations in a way that's meant to be helpful. After all, artificial intelligence is just a fancy way of saying software that learns by example. 75? This is a place where semantic shortcuts loom large. And while the comparison with agents, with a personal assistant is helpful in some respects, it's misleading in at least one important way. When Sam, your human personal assistant, screws something up, maybe he booked you a flight to Australia instead of Austria, you can tell him, wow, you really screwed that up. Next time, please make sure to... When you do this, you're treating Sam as a single, coherent entity. You don't talk a bit to his prefrontal cortex and a bit to his visual cortex and some more to his medulla oblongata, let alone to these neurons and not those neurons. On the other hand, when an AI agent goes sideways, the source of that error can come from all sorts of places. Maybe it comes from the agent itself, the LLM with which you interact, but it may just as well come from any number of tools to which the agent is connected, the databases, other AIs, other non-AI software. And to get the AI agent to do better next time, talking to the agent in the way you talk to Sam may not be helpful. You may well have to work on the tools to which the agent is connected to get your agent to do better next time. Managing the behavior of an agent is therefore very different from managing the behavior of a person. In fact, the more I look at the previous chapter's diagrams of AI agents, the less I see something analogous to personal assistants. Instead, I see something closer to various phenomenally complex engineered creations. I'm thinking of things like commercial jets, rocket ships, military submarines or warships, and nuclear plants. These things are not operated or maintained by an individual. That would be impossible. Any one of these systems is too complex for that. Instead, these great machines are designed, built, tested, operated, overseen, regulated, and maintained by scores of teams of cross-disciplinary experts. These sophisticated technologies require sophisticated human organizational systems. When you invent the submarine, you must also invent the dozens of teams that will operate and maintain it. The history of innovation is not simply the history of new and powerful technologies. It's also the history of how we invented new and powerful ways of working together so we could use those technologies responsibly. When I see AI agents as personal assistants operated by a single individual, aka the end user, I'm skeptical about the future of agentic AI. There are too many systems, too many points of failure for a single individual to responsibly manage this behemoth. It would be like manning a rocket ship with just the captain. Even Kirk needed a crew. But I find this alternative framing, multi-agentic AI, as complex engineered systems that require teams of experts to design, build, test, operate, oversee, and maintain, a source of optimism for the agentic AI future. We know we can build and operate complex technological systems that operate in extremely high-risk contexts, and that we can do it safely. The mistake many technologists make is to think that those complex human organizational structures we build to operate high-risk technology safely can be AI-ified in anything like the near future. You can't automate all the things at once. So yes, build your powerful multi-agentic AI ecosystems, but recognize that the more complex those systems are, the more we need teams of humans in the mix. The success of agentic AI does not depend upon replacing humans. It's precisely the opposite. Will there be a day when AI agents can themselves replace those complex human structures that work to ensure we don't blow ourselves up? Could it be AI agents all the way up and down? Maybe one day. Until then, as we grow new and powerful AI systems, we need to invent new and powerful ways of working together. Can we pull off such a feat? Well, if we've done it for submarines and fighter jets and commercial planes and nuclear plants, I'm optimistic we can do it for AI. That's exactly what the second half of this book is about. Thanks everyone for listening. I hope you enjoyed the episode, and I want to thank a few people who make this all possible. Delano Alexander, he's my producer. He does such an amazing job on everything that he touches. Garrett Lang is the sound engineer. That's honestly, he's too good for me. Athmia Jairam has joined us recently. He's helping us find the best guests to bring onto this podcast. And Ashley Wasilenko helps us organize all this, get people on the schedule, get people's bios, headshots, and really keeps the train on the track. So thanks, guys. Really appreciate all the hard work you do.